So working with right triangles, we talked about two main ideas this year, the Pythagorean theorem, which helps us find side lengths, and trigonometry, which helps us find side lengths or angle measures. So both are listed here, your a squared plus b squared equals c squared for Pythagorean theorem, sine, cosine, tangent, and their associated ratios for trigonometry. So for the first problem, it says which method would you use and why? So for part A, technically you could use trigonometry to find one of the acute angle measures, and then use trigonometry again to find the side length. However, the faster method would be to use the Pythagorean theorem. You know, two of the sides, you have a right triangle, you can put it into that equation. For part B, you cannot use the Pythagorean theorem. You only know one side, and you don't know how this blank side relates to this variable x. And the nice thing is you know an acute angle, so that's another clue that trigonometry is the way to go. So looking at the second example, we've done this problems like this over and over again, but it's worth talking about. You have to look for right triangles. So for instance, in this case, I'll kind of speed up the problem. What you're actually looking for is the ship's distance from A to D. So if I just look at A to D on its own, and I put it in a triangle, it's in this obtuse triangle. So it's not in a right triangle. So I can't use trigonometry, I can't use the Pythagorean theorem. However, I do notice that if I go from A to C, go up to B, there's a right triangle. If I go from D to C and up to B, there's another right triangle. So the strategy would be to find the distance of, I'm calling it W, so the length of A to C, that larger length in the bigger right triangle, and compare that to this other right triangle, find Y. So I redrew the bigger triangle just to look at it. Again, it's all about labeling. So this degree measure of 7, I look at that as my reference angle. Opposite that is 125, and adjacent is what I want to find. So that's my W. I have to definitely include that. So I need the adjacent side, and I only have the opposite side. So that means I have to use tangent. So I did tangent of angle 7 equals the opposite side of 125 over W. If you cross multiplied, you would get W times tangent 7, and you have to divide out the tangent 7. So remember, cross multiply if you need to, and go from there. Pop that in your calculator. Make sure you're in degree mode. The next triangle also uses tangent, also uses the same process of, instead of multiplying the final values, I divide by tangent. And then I just use a little bit of subtraction to find the length of A to D. So this problem on the back, a little bit more involved in terms of what they give you to begin with, so we'll take our time and explain that. So you have this flagpole, and you have two cables, R and S, and the flagpole is 16 feet above the ground where they're attached. The combined length of the cables is 50, so I circle that, keep that in mind. So it says cable R is attached to the ground 12 feet from the base of the pole. What's the measure of this angle over here, X? That's your angle of technically elevation up to the flagpole. So we eventually want to get to this angle, but sometimes we can't get there right away. So let's see what we have. I always say look for things you already know. So you know in a right triangle, if you have two side lengths, you can find the remaining side, in this case the hypotenuse. So I found that first with the Pythagorean theorem. Then I said, okay, how can I incorporate, again, this circled piece of 50? Well, these have to add up to 50. So if this is 20, this must be 30. Now you're in this triangle on the left side, and now you can use trigonometry to find this angle measure. So same strategy as finding sides in terms of look for the ratio. So in this case, this would be opposite over hypotenuse. Those are the two pieces you know. The missing piece in this case is the angle. So I can go to my trig inverse function on my calculator. So it should look like this. And what you tell the calculator is the ratio of the sides, and the answer will be the angle. So in this case, it ends up being 32 degrees. This is a little bit more conceptual in nature. So the last couple problems here, try to get you to make connections. So I wrote out a few connections that I saw. So I didn't put numbers in. I just looked at these letters. I said sine of A would be the opposite over the hypotenuse, say A over C. Sine of B, I'll go over here, would be opposite B over C. I wrote those down. Then I'll take cosine of the acute angles as well. So cosine of A would be adjacent B over C hypotenuse. Cosine of B would be adjacent A over C of the hypotenuse. So the connection is both sine and cosine divide by the hypotenuse. Okay, so you have that in common. But depending on what the angle is, the opposite and the adjacent can be the same. So what I mean by that is sine of A, the opposite side is A. However, cosine of B, the adjacent side is also A. So sine of A equals sine of B, as long as you're in the right triangle and they're acute angles. And same thing, cosine of A equals sine of B. So the connection is the only way that sine and cosine are going to be equal is not that the angles are equal, but the angles left over add up to 90. So we can write this finding down here. I know that sine is equal to cosine as long as they're complementary. So whatever this angle is, I subtract it from 90, and that would be cosine's value for the angle. And same thing with cosine and sine. So a couple ways I could ask you this. You could just know this and kind of play around with it algebraically. You can use your calculator to work through the problems as well. So I want cosine and sine to be equal. They're giving me x values. So one strategy is multiple choice. Use that to your advantage. Go to your calculator and put in cosine, parentheses, 2 times, let's try -7 minus 1. Press enter. You'll get some decimal. Try -7 for the x value and the sine. It won't be the same. Okay, so they're not equivalent. If you put in 17, things will work out for you. I'll do that quickly. Again, make sure you're in degree mode. The other thought on that is, actually, I'll give you the decimal. You get 0.83867. If you put 17 in for the x value of sine, same decimal, yeah, they're equal. The algebraic version of this would be to say, okay, cosine and sine are equal if the angles that I input add up to 90. So I just set up a little equation here, linear equation, and solved from there. This one doesn't have any numbers. Strategies are make something up or look at the angles, or just know this idea that if the angles are complementary, sine of the angle and cosine of its complement will be equal. So different ways to kind of work through that.